धरती ने करवट क्या बदली, कांपी धरा और अंबर भी। धरती की पीड़ा को समझा मानव, जब सब ध्वस्त हो गया। पर जिजीविषा जीवन की उसको स्फूर्ति दिलाती है, इसीलिए नवयुग के सुंदर नव निर्माण कराती है।
टेक्नोलॉजी ऑफ होम भारत में निर्माण की बेहतरी के लिए शैक्षणिक जगत के साथ साथ उद्योग के प्रतिष्ठित दिग्गजों द्वारा ज्ञान साझा करने का एक स्वतंत्र मंच है। ये जेके सीमेंट और एसोसिएशन ऑफ इंफ्रास्ट्रक्चर इंडस्ट्री इंडिया की एक संयुक्त पहल है। इस पहल में एक आम आदमी की मदद करने के लिए ये सुनिश्चित करेंगे कि वो एक मजबूत सुंदर घर बनाने के लिए उपयोग की जाने वाली सामग्रियों की उपयोगिता और प्रक्रियाओं से पूरी तरह अवगत हो, जिससे उसके घर के निर्माण के लिए धन का उपयोग ठीक से किया जा सके। तो आइए हम सुनते हैं प्रोफेसर डॉक्टर कौस्तुभ दासगुप्ता से अर्थक्वेक रेजिस्टेंट स्ट्रक्चर्स के बारे में।
The way one person should look at is first refer to a standard document known as Indian Standard for Earthquake Design, and that document has a seismic zone map, okay, in which the entire country is divided into 4 seismic zones. So our zone 5 is the most earthquake prone area and zone 2 is the least one. During earthquake shaking, what happens? The vibrations start from the ground level and then the shaking gets propagated upward in the vertical direction. Now if you are looking at a brick masonry house, which we commonly see in the rural areas, there we can have the damages in the bed joints of the mortars, okay? Even the bricks can themselves get crushed, the walls can themselves get collapsed in the in plane or out of plane direction. The primary intent is that if you have a large number of earthquake shaking of minor intensity occurring over the year or over the entire service life of the building should remain undamaged. However, not that frequent earthquake which have large shaking can cause damages, but those damages should be repairable. First, let us talk about the reinforced concrete building or the frame building. There we need to provide a special type of detailing and configuration for the steel reinforcement bars which we are going to use in beams and columns. So that detailing is known as ductile detailing. When we have the reinforcing bars in the columns, when we take 2 bars and we try to provide the entire height through these overlap lengths, right? So these lap lengths or these overlapping regions should not be at the floor level or at the roof level. It should be at some intermediate story location, at intermediate height. Then when we look at the reinforcement in the columns or in the reinforcement in the beams, we also see that the main reinforcing bars are enclosed by such rectangular configurations. These are known as stirrups in beams or the ties in columns. For the brick masonry building, when you look at the roof, you already have some roof slab which is kind of holding the walls together of the brick masonry building. At the lintel level, just above the door or the window opening, you must have a continuous reinforced concrete band running all along the periphery of the home. Okay. Similarly, at the window sill level, okay, leaving apart the door openings, such reinforced concrete band should run. Same thing should happen at the plinth level also. A reinforced concrete band should run. So these bands are primarily intended to hold all the walls together. When the entire building tries to shake during earthquake, the walls should not be behaving on their own. The bands are supposed to hold all of them together. So the plan of the building should be such that the symmetry is maintained as much as possible. The reason being, once you have the earthquake shaking, the asymmetric nature tends to twist the building, which can be extremely detrimental. Okay? So that is the planned symmetry. If you look from the vertical point of view, then the shape should be as much as straight vertical. Why is it so? Because we frequently use 2 type of configurations known as floating columns and setback columns. If you have a column coming from the roof level and then it suddenly gets terminated at the first floor level, that is called a floating column. whatever is carrying the load from the roof to that first floor level needs to find a proper way to transmit the load to the foundation. So the connecting beams need to be designed for that. Similarly, you can have setback columns also, where again such vertical irregularity can happen. So floating columns and setback columns must be avoided. So specifically in zones 3, 4 and 5, when we are providing the foundation in terms of shallow footing, just rectangular footing at 1 to 1.5 meter depth below the ground level. So all those footings should be tied by a foundation beam, also known as tie beam. We need to have proper geotechnical investigation to ascertain the soil properties, whether shallow footing will suffice or you need to go for deeper foundation, right? So that is the second aspect. Third aspect is that from seismic characteristics, we use a term liquefaction, in which the soil tends to behave like a liquid during heavy earthquake shaking. Okay, so there are specific properties of the soil under which it can liquefy. When we look at the requirement of water tanks, we have to provide water tanks. Those water tanks should be secured to the rooftop, either to the building columns by making the water tank as monolithic reinforced concrete with the columns, or you need to have some anchor bolts or fasteners which also need to be designed against the unseating. For the staircase part, better practice is to separate out the staircase tower from the main building. The staircase itself is a standalone tower. So let it vibrate on its own. Let the vibration not affect the beams and columns or the brick masonry building itself.
प्रोफेसर डॉक्टर कौस्तुभ दासगुप्ता, एसोसिएट प्रोफेसर सिविल इंजीनियरिंग विभाग IIT गुवाहाटी, एक युवा और प्रेरित शिक्षाविद हैं, जिनकी विशेषज्ञता स्ट्रक्चरल इंजीनियरिंग में है। उनके शोध के क्षेत्र में प्रबलित कंक्रीट संरचनाओं के भूकंपीय व्यवहार और भूकंपीय मिट्टी संरचना की पारस्परिक क्रिया शामिल है। टेक्नोलॉजी ऑफ होम, सुदृढ़ सुंदर निर्माण।